Hey, it's Bobby from brewhardware.com, and we're going to spend a little bit of time in this video going over the topic of pump maintenance and troubleshooting. Now, chugger pumps, like the ones we sell at brewhardware.com, are generally reliable and only require sporadic maintenance. But like all other magnetic drive pumps that are used for brewery applications, we do have to sometimes troubleshoot a fouling of the head or a misalignment, just due to how rough we are with these pumps and how we expect a lot of sort of coarse material to pass through the head on a pretty regular basis, such as hop pellet material, or sometimes whole leaf pellets will get in here. And it's important as a pump owner to not be afraid of taking these apart to a certain degree and troubleshooting issues. And with some of the information you're going to get in this video, I don't think you'll have any trouble making some minor repairs. Now we'll quickly just review the exterior components and their names. This is the pump head, this is the pump head mounting bracket or mounting ring, and this is the motor. Now, you're probably aware that the pump heads are somewhat interchangeable on these chugger pumps. This happens to be the inline stainless steel version. There's an inline plastic version that's black, and then there's also the stainless steel center inlet that has the larger male thread on the front of the head here, right here. Now, aside from the general build of the head casing itself, the interior of the head, the mounting ring, and the motor are all identical across all of these pumps. So most of what I'm going to describe in here is going to apply for all three head styles. So let's get started taking this apart. Once you do that, the head will come off. Don't lose the screws. So this is the head assembly. You notice that it includes this stainless steel stamped cover plate on the back, which is held on with its own screws. Now this is called the head assembly. So this is the interchangeable piece. If you were to upgrade from like a plastic head pump to a stainless, this is the assembly that you would get, and it would just interchange with those 4 screws. Now inside the mounting ring or the mounting bracket, you'll see the cup magnet. Now this cup magnet is solidly attached to the motor shaft on the motor, and when the pump is running, this cup magnet is spinning. Now the impeller is on the inside of this head assembly, and there's also a magnet that sticks into this this bump out in the back of the head. So when you put this together and the motor's turning the cup magnet, it in turn turns the impeller within the head. That's why it's called a magnetic drive pump. Now let's go over a couple of troubleshooting steps if the pump stops working to your expectations. There are a couple of situations that will impact the performance of the pump or stop it from working at all, and they're really simple to identify and correct for. Now let's say the first problem is that you plug the pump in and it won't even turn. The motor won't even turn. Now, it could be a faulty motor, but most likely it's not. The first troubleshooting step is to remove the head using the 4 screws on the face of the head, like we've done here, and then go ahead and plug the pump in. All right, the fact that the motor is spinning freely means that the motor is not bad in and of itself. There must be something else going on. Now, one thing I want to bring to your attention is that the cup magnet is attached to the motor shaft, so that really can't move left or right or up or down. But the mounting ring or head mounting bracket does have a little bit of movement capability. Now, I'm not sure if you can see it, but the cup magnet here is not concentrically centered in the opening of the mounting bracket. And what that means is that when the head is attached to the mounting bracket, this impeller protrusion here is not going to be perfectly centered within the cup magnet. And again, because these tolerances are so tight, there could be some contact made between the back cover plate of the head and the cup magnet. So this could simply be an alignment issue. And you can also verify, you might want to look on the cover plate of the head and look for abrasion marks. What normally would look like is a shiny section where the cup magnet was kind of polishing a certain spot on here, and that would be a telltale sign that you have a contact issue between the cup magnet and the back of the head. Okay, so how do you correct for that? Well, the 4 screws that are holding the mounting bracket to the motor housing itself can be loosened. And you don't have to take these screws all the way out, but you want to back them off enough so that they're not applying any pressure to the flange anymore. So those are generally loosened up. I can verify that I can get a little play in the mounting bracket. And you can move it around and try to figure out how to make that gap completely symmetrical all the way around. And once you find a spot where that's the case, kind of hold it in place with your hand and then retighten up these screws. You don't want to over tighten these, of course. You don't want to strip them out. So even though I'm using a drill driver here, you might want to use a handheld screwdriver for this purpose. So again, you can reinstall the head now that you've recentered the cup magnet. And I should mention also that at this point, you can also reorient the head in any position that happens to be convenient for your setup. One thing I do want to warn against, though, is that if the pump is being mounted with the bracket side down, what you don't want to do is position so that the outside of the head is facing down. This is the most troublesome position as far as getting the head to flood with liquid and start pumping. So my recommendation is to either install it with the out going off to the side like this, or the out facing straight up. This is another totally acceptable way of mounting the head. And then you put your 4 screws back in and you should be back in business. Troubleshooting condition number 2 is when you plug the motor in, the motor spins fine, there's no trouble there, but you cannot pump any liquid, or the liquid does not pump. The first condition that might be causing that problem is that you haven't fully primed the pump. Now, this may be the case for new pump owners who are just not as familiar or practiced with getting the pump primed. And so let's go over those steps real quick. So priming the pump means flooding the head with liquid such that there is no air in the head itself or in the line leading to the pump input. Bottom line, these pumps are not self-priming. So if you're absolutely positive that the pump head is flooded and there's no air in the line leading up to it, then you may have condition number 2, which is that something is fouled inside the head itself. If the pump motor is spinning, but no liquid is pumping, and you're sure there's liquid in the head, then something must be obstructing the impeller from turning. Again, because these are magnetically driven pumps, there is that magnetic coupling that's made between the cup magnet and the impeller magnet, which can be broken and therefore not move the impeller at all. So troubleshooting this requires that we take the head off the motor like we've seen before, but now we have to disassemble the head. Now, this is the same step you would take if you had any leaking problems, if you saw water or any liquid leaking out of the head, because this also will expose the seal. So you take these 4 Phillips head screws out of the back plate. All right, so here is the O-ring. It's a clear, thin O-ring that sits in a groove on the head, and when you screw the back cover plate on, it makes contact there. If you had any leaking issues, by the way, you would want to inspect this O-ring for tears or for any foreign material that might be laying across it, like hair or something like that, and perhaps just reseat the O-ring with a little bit of petroleum lubricant. All right, So while we have this open, why don't we just go over the parts that are inside here. First of all, this is the back cover plate of the head. This is the large thrust washer. It's a plastic washer that goes in the back, and that provides a bearing surface for the impeller to ride on. Then we have the impeller. This is the impeller magnet and the impeller blades itself. This is one piece unit that doesn't come apart. And then the last piece is the thrust washer that goes on the front of the impeller on the impeller shaft. Now, most of these interior components can be replaced if they do wear out. In some older pumps, you will see some wear on the thrust washers. Those are bearing surfaces, so they will wear out. If you've got issues with the head making a rattling sound often, it's most likely because the thrust washers are being worn down and there's too much play in the head. Now, if you had an issue where the pump was running but the liquid was not flowing, by the time you get this cover plate off and inspect the interior components, you may already find the culprit. It's probably some foreign material or debris in the pump head that is causing the impeller to not turn easily. If nothing is apparent upon visual inspection, the next thing you want to do is, with the thrust washer in place and the impeller on the shaft, give the impeller a quick spin with your finger. You should see that it makes about 5 or 6 rotations on its own without binding or slowing to a quick stop. For example, if you spin it and it comes to an abrupt stop like that, like it barely wants to spin free, then most likely you have an issue with fouling on the impeller shaft or inside the bore of the impeller. Now would be a good time to scrub this with some PBW, perhaps the scrubby side of a sponge to break up any beer stone that may have accumulated on the shaft. See if it's smooth or if it's sticky. And then also you can soak the impeller in some hot PBW and run a nylon small brush through the bore to make sure that that's squeaky clean, and then put it back together and see if you can get it to spin like that, nice and free. Of course, inspect the thrust washers for excessive wear and replace those if necessary. And once that's cleaned up and verified that it spins free, you should be able to assemble the head back together again. Again, beware of any foreign materials laying over this gasket, like human hair or any kind of dust. Make sure that it's nice and clean. And then you can go ahead and replace the screws that hold the back cover plate on. Now, there are certain cases where customers will report that the pump works fine when the liquid going through it is cold or in the very beginning of brew day, but then as the brew day progresses and everything gets hot, that's when problems arise. Now, it stands to reason that if there had been any mechanical interference between the cup magnet and this back cover plate, it would be less of a problem when everything is cold, because everything shrinks a little bit when it's cold, and then as it heats up, the clearance between here and the cup magnet becomes less and less. So perhaps there is no problem, or I should say the problem is less when the head is cold, but gets worse as it warms up. Again, the remedy is exactly the same, but I just want to make sure that people are aware that sometimes the temperature just exacerbates the problem that already exists when it's cold, so it still needs to be remedied. So the next troubleshooting scenario I want to talk about is pump failure due to overheating. Now, these pumps will stop pumping completely. The motor will not turn if the pump overheats. And there's a couple scenarios that cause this, and sometimes it's just based on user misunderstanding. Now, the first reason why a pump may overheat is that the extension cord that you're using is either too narrow of a wire gauge or the length of the extension cord is too long. If you're going to go over 25 feet, make sure that you're using 14 gauge or 12 gauge extension cords. And you really should not exceed 50 feet, because at that point, the voltage drop is such that the pump is going to work that much harder and overheat. Now, another reason why these pumps will overheat is because customers install shrouds over these, or like splash guards, and these motors use the cooling fan in the back here and the vent holes in the pump body to provide cooling for the motor coils, and you cannot really restrict the airspace around these pumps because it can't vent the heat fast enough. So if you're going to do any kind of shrouding for these pumps, just make sure that the clearance between that shroud and the pump motor is like 5-6 inches out like that, and that the top is well over the pump. Please do not put like coffee can shaped shrouds around these pumps. All right, that's definitely a problem. Also, mounting these pumps too close to burners, for example, if you've got like a banjo burner, you know, really slamming like 6 inches away from this pump and all the heat's reflecting off the bottom of the pot, then again, there's a pillow of really hot air right around the motor where it's trying to vent and keep cool. Either reposition the pump somewhere else, much lower or further away from the burner, or install a heat shield underneath your burner so that all of that heat does not come down onto the motor. Along the same lines, we've seen customers install these pumps inside toolboxes to be able to put switches and controllers, and also conceivably to keep water off of the pumps. Again, same problem. These pumps are not meant to be installed in enclosed spaces. If you do want to put this into a box of some sort, at the very least you have to install additional venting and another fan to be able to blow air through the enclosure to keep these pumps cool, especially if you have two pumps in a toolbox or any other electronics that generate heat inside that enclosure. Now, the last scenario that we may need to troubleshoot is what's known as magnetic decoupling. And that can be described as the condition where the motor's spinning just fine, the head and its internal components have been verified as clean, and the impeller is free spinning, but for some reason, no matter what you do, you just can't get this pump to move any liquid. Again, discounting the fact that you may not have the pump fully primed and you're not experienced enough to realize that. The last possibility is that the cup magnet is not conveying strong enough magnetism to the impeller magnet, and therefore it's losing its coupling. Again, making sure that the thrust washers are not fully worn out and that it's causing the impeller to hang up. You may have an issue with the magnetic coupling. And this has been diagnosed as being a problem with the cup magnet's magnetism, such as the magnet's losing magnetism, which is not totally impossible, but it's most likely not the case. One of the primary reasons why this may happen is the case where a user takes the mounting ring off of the motor and cuts a similarly shaped hole and series of holes into the side of any kind of material, whether it be the side of a toolbox, some kind of enclosure, or some custom mounting bracket, and then sandwiches that material between the motor and the ring for mounting purposes. Now, when you put any spacing or gap between these two components, what it's doing is retracting the cup magnet back from where the head has to be positioned. Now, for this to fully work and pump strong, that cup magnet has to be practically touching the back of the head. Now, again, to have maximum magnetism, it has to be close tolerance. And you can imagine as this moves further and further away from the motor, you're moving the two magnets apart. So account for it by adjusting the cup magnet. Now, this is held on to the motor shaft with a Allen key set screw. Now, this is a 3mm Allen key, and there's a set screw right there. And if you loosen that, you can take the cup magnet off. So that also means that there is a little bit of adjustability as far as the depth is concerned. So you can reposition this so that it comes out further. Use a ruler that's generally accurate and verify that the cup magnet is only set back a max of 1/8 of an inch, if not a touch less. So you can verify the depth and then use your set screw to reposition the cup magnet and make sure that you tighten it really well before you put the pump back together. So hopefully this video has taken some of the mystery out of the internals of the Chugger pump. Again, as a pump owner, you should be prepared to at least go down to this level of disassembly to troubleshoot the pump. There's going to be issues that arise over the life of the pump that's well beyond the warranty period, and rest assured that these are all replaceable parts, and any of the misadjustment or fouling can be easily dealt with as long as you're not afraid to take this apart. Good luck. Any additional questions, of course, let me know. You can email us at info@brewhardware.com or give us a call at the shop. Thanks for watching and happy brewing.